were all it took to change the sky forever, because the moment a small artificial object began circling the Earth silently above every border, ocean, and battlefield, humanity realized that the planet itself had entered a new age, an age where space was no longer distant or unreachable, but something that could be used, controlled, and depended upon. And long before satellites guided our phones, predicted weather, streamed global media, or tracked every movement on the planet, the idea of placing machines above Earth felt almost unbelievable. Because for most of human history, the sky was a realm of mystery, gods, stars, and untouchable distance. And this story does not begin with smartphones, GPS, or the internet, but with fear, ambition, and a world standing on the edge of destruction. Because before satellites existed, humanity's view of Earth was fragmented and incomplete. Communication depended on cables laid across oceans that could be cut. Radio signals faded with distance. And interference. Navigation relied on stars, maps, and guesswork, and military intelligence depended on spies, aircraft, and partial information. And as the 20th century progressed, the world became smaller, but also more dangerous, because global war and nuclear weapons meant that decisions made in minutes could determine the survival of entire nations. And during the tense years after World War II, the United States and the Soviet Union faced a terrifying problem that would reshape history. How do you know what your enemy is doing without crossing their borders? How do you communicate instantly across the planet? And how do you detect an attack before it is too late? And it was inside this pressure that the idea of artificial satellites moved from science fiction into strategic necessity. Because scientists had long understood in theory that an object moving fast enough sideways could fall around the Earth instead of crashing back down. An idea predicted by physics centuries earlier, but it took the Cold War to turn theory into reality. Because rockets powerful enough to reach space were also rockets capable of delivering nuclear warheads. And as nations raced to master missile technology, they also unlocked the ability to place machines into orbit. And in 1957, the world looked up in shock as the Soviet Union launched Sputnik 1, a polished metal sphere no larger than a beach ball that did nothing more than emit a simple beeping sound as it circled Earth. Yet that sound echoed louder than any weapon, because Sputnik proved that space was no longer a natural barrier, that machines could pass freely over every nation without permission, and that whoever controlled space could see, communicate, and potentially strike from above. And the psychological impact was immense, especially in the United States, where Sputnik triggered fear, urgency, and a sudden realization that technological dominance was not guaranteed. And from that moment, satellites were no longer scientific curiosities. They became essential tools of survival, and governments poured massive resources into space programs, leading to rapid advances in rocketry, tracking systems, orbital mechanics, and electronics. And early satellites were designed primarily for military purposes, because during a nuclear age, the ability to see and communicate was as important as the ability to fight. And reconnaissance satellites replaced dangerous spy planes by photographing enemy territory from space, fundamentally changing intelligence and making secrecy increasingly difficult in a world watched from orbit. And at the same time, communication satellites emerged as solutions to one of humanity's oldest problems: how to send information reliably across vast distances, because radio waves traveling along Earth's surface were limited by curvature and interference. But a satellite placed high above the planet could act like a mirror in space, receiving signals from one side of the Earth and relaying them instantly to the other, collapsing distance in ways never before possible and allowing live communication between continents for the first time in history. And as engineers refined satellite orbits, including geostationary paths where satellites appear fixed above one point on Earth, the skies slowly filled with invisible infrastructure supporting modern civilization, and satellites began to move beyond military needs into civilian life, transforming how humanity understood and interacted with the planet. Because weather satellites allowed scientists to observe storms forming over oceans, track hurricanes days before landfall, predict rainfall, and issue early warnings that saved countless lives, turning weather forecasting from guesswork into science. And Earth observation satellites revealed patterns of deforestation, climate change, ice melt, and urban growth, allowing humanity to see itself from above for the first time. A perspective that reshaped environmental awareness and global responsibility. And navigation satellites quietly revolutionized movement itself, because systems like GPS allowed precise positioning anywhere on Earth, ending centuries of navigational uncertainty and enabling everything from aviation safety and shipping efficiency to smartphone maps, emergency response, and global logistics. And this transformation happened so smoothly that most people never realized how deeply dependent daily life became on machines orbiting thousands of kilometers above their heads. And satellites also reshaped science by placing telescopes above Earth's atmosphere, allowing humanity to observe the universe without distortion and revealing galaxies, stars, and cosmic phenomena that changed our understanding of existence itself. And as satellite technology advanced, these machines became smaller, cheaper, and more specialized, leading to massive constellations of satellites working together to provide global internet access, high-resolution imaging, and real-time data streams, turning space into an extension of Earth's infrastructure rather than a distant frontier. And yet, for all their benefit, satellites also introduced new challenges, including space debris, orbital congestion, surveillance concerns, and questions about privacy, power, and control. Because a world constantly observed from above raises ethical dilemmas humanity is still learning to navigate. And when we ask why satellites were invented, the answer is not simple. Because they were born from fear of surprise attack, desire for communication, hunger for knowledge, and ambition to overcome Earth's limits. And satellites exist because humanity needed eyes that never blink, messengers that never sleep, and systems that operate beyond borders and politics. And today's satellites guide airplanes, synchronize financial markets, enable disaster response, monitor climate, support science, and connect billions of people who may never look up and think about the machines quietly circling overhead. And as we stand on the edge of a future filled with space-based solar power, planetary defense systems, and interplanetary exploration, satellites remain the foundation of humanity's presence beyond Earth. The first machines to make space useful rather than symbolic, and their greatest legacy is not metal or circuitry, but perspective. Because satellites taught humanity to see Earth as one connected world rather than many divided ones. And as night falls and artificial stars move silently across the sky, they remind us that the most powerful inventions are often invisible, operating above us, shaping life below without drawing attention.